It's time for us to actually prove if a triangle that's given to us is a right triangle or not. And so we know that the right angle would be here if it was a right triangle, right? It may not be. And we also know that the right angle would be right here, but hey, it might not be 90 degrees. Maybe it's 89 degrees. Maybe it's 87. It looks like it, but it's not. So how can I prove this without getting a protractor? Well, if we use the Pythagorean theorem, which I'm hoping at this point that you guys already remember is a squared plus b squared equals c squared. And that you can remember that, hey, the sides that are part of the triangle that touch the right angle are your a's and b's. So these are sides a and b. And then that leaves the third side being your c, your hypotenuse, right? Well, after you've discovered your A and B's and your C sides on this triangle to go test, take them and put them into this Pythagorean theorem. So this 4 is what we called A, and so we'll put it right here, 4 to the second power, right? Then B is 3, so this would be 3 to the second power, and 5 would be C, so we pop that in right there. It makes it 5 to the second power. Now, the plus sign is still sitting there, and the equal sign is still sitting there. Now, I'm going to show you some strategies that will help you not make a mistake. You can do it in a lot of different ways. You can do it in your head a lot of times, but we're going to be getting to a lot bigger numbers, and so let me just show you how the calculator can get you through it with minimal pain. You can see here that this is the classroom calculator that I have, but about any calculator will work. TI-34 multi-view. I want you to type in this whole part right here, the 4 squared plus 3 squared. How do we do it? Well, you type in the 4 obviously, but if you look right here, see x to the second power, if you hit that, it automatically puts a second power up there, and it's ready for you to go ahead and hit the plus sign, and now just type in 3 to the second power. What's it equal? 25. So when you're using the calculator, you can just go and plug that straight in, and that's nice. Now you can do it without a calculator. 4 to the second power is 16. 3 to the second power is 9. What's 16 plus 9? 25. You can also go and use your calculator and go, hey, what's 4 to the second power? And then write 16 underneath it. But when you have your calculator, I would just recommend just adding your a squared and b squared together once you have those numbers in, and then just calmly putting it down as one number. Now, this will be a right triangle if this c squared over here equals whatever we got on this side. The a squared plus b squared equals 25 combined. So c squared, 5 to the second power, is indeed 25. And so because these two numbers equal each other, you would say, well, yes, this is a right triangle. And you can actually memorize this when it shows up so often. A 3, 4, 5 triangle will be a right triangle. Okay. But now what happens, we need a nice example about what happens, how can I prove if it's not a right triangle? So let's go do this one together. You can see this side right here would be touching the right angle, so let's just call that one A. And then let's go and see what the other side that's touching this would be your B. That means that the 9 would have to be my C side. The other thing is that your hypotenuse has to be the biggest of the triangle. So your biggest number should always go into C. And if you come back over here, your C side is always the biggest. And so 5 should automatically go into C. And then we really don't care which one is A or B, right? We're just adding them, squaring them and then adding them. It doesn't matter. But this has to go into C. And so to go test it, let's go try it one more time. Let's write out the Pythagorean theorem relationship. A squared plus b squared equals c squared. So A is 8, B is 6. In this case, you could have had it 6 squared plus 8 squared, right? But the C, your hypotenuse, it has to be 9 squared. And so now I can come right over here to my calculator. Perhaps I'll just put it on this side right there. I think we can get it to where you can see that. Yeah. 8 squared plus 6 squared. I type it all in at once. I commonly see that it's 100. And so I know that these two squared and added would be 100. I have to get 100 on this side from my c squared in order to say, yes, this is a right triangle. Well, 9 to the second power is 81. 100 does not equal 81. This relationship is true in right triangles. So after I plug the sides into the Pythagorean theorem, if it doesn't equal a true statement, I know it's not a right triangle. Okay, so if these two numbers don't equal each other, it's not a right triangle. If these two do, yes, it's a right triangle. Please just make sure that your biggest number always goes in for C.